Hi everyone, it's Mrs. Sommer here to talk about the Unit 3-4 review. So the first question is, Joanna was at home bored on the weekend. She decided to do an experiment. She has seen someone put Mentos in a Diet Coke and wanted to try it for herself. While she was doing this, she wondered if it was a chemical reaction. What would you tell her? What evidence of chemical change would you use to support your claim? So I have this video here of a kid putting a Mentos in a Diet Coke. And wondered if it was a chemical change. What would you tell him? What evidence of a chemical change would you use to support your claim? And then, yes, this is also a chemical change, and a color change had occurred. The next question has you labeling all of the parts of this chemical equation, using the vocabulary terms on the left to make sure you've labeled everything. So my first one is going to be my reactants. My reactants are both the CH4 and the O2. My products are my CO2 and 2H2O. This is my yield sign. The little number, the arrows pointing to the 4, is subscript. And the number in front of H2O is the coefficient. The next question is write a sentence for the reaction above. So CH4 is methane. So the sentence would be methane plus oxygen reacts to form carbon dioxide and water. The reactants of the chemical equation are CH4 and O2. And the products are CO2 and H2O. This is a combustion reaction. The last question on this page is describe the difference between what the coefficient and the subscripts mean in a chemical equation. So here we have a subscript tells you the number of each atom. The coefficient tells you the number of each molecule. On this page, it has you counting the number of the number of atoms in each of the following compounds. In H2SO4, there are 2 hydrogens. There's 1 sulfur and 4 oxygens. In 3Li-H2PO4, we have 3 lithiums. 3 times 2 is 6 hydrogens, 3 phosphoruses, and 12 oxygens. In CrMnO34, we have 1 chromium. We have 4 manganese and 12 oxygen. In 2H6SO4, we have 12 hydrogens, 2 sulfurs, and 8 oxygens. In 4PbNO32, so lead nitrate, we have 4 leads. Let me write that a little bit better. We have 4 leads. We have 2 times 4, so 8 nitrogens. Oxygens, we have 2 times 3 is 6. Times another 4 is 24 oxygens. In 2CaC2H3O22, we have 2 calciums. We have 2 times 2 is 4 carbons, times another 2 is 8 carbons. Hydrogens, we have 3 times 2, 6, times another 2 is 12. Oxygen, we have 2 times 2, times another 2 is 8 oxygens. And in this last one, we have 7 times 2 carbons, so 14 carbons. And 7 times 2 sulfurs, we have 14 sulfurs. In this question, it says, explain your process to find the number of each atom. So in the counting atoms one. So in general, your answers will vary, but you must multiply the coefficient by the subscript for each element. if there is parentheses, you multiply whatever in the parentheses times the number on the outside of the parentheses and then multiply by the coefficient. The next section is label the following reactions as one of the 5 types of reactions, and then explain how you know each type. So the first one is a synthesis reaction, and I know this because I have 2 substances that are being combined to form just one additional substance. The next reaction is a combustion reaction, and I know this because a hydrocarbon, or a carbon and a hydrogen compound, is reacting with oxygen to form carbon dioxide and water. The next reaction is a single replacement reaction. I know this because the solid metal right here, copper, replaces the silver, and then the silver here ends up being all alone in its products. So it was basically kicked out of the relationship. This next reaction is a double replacement reaction. The metals in each, so there's potassium and lead, swap places in the products. So the lead then goes with iodine and the potassium goes with the nitrate, and no element ends up all by itself. This last reaction is a decomposition reaction. We have one substance here decomposing into 2 different substances. So this next section is balancing chemical equations. So on my reactant side, I start off with 1 magnesium, and I thought this was magnesium oxide. It is not, so I'm going to cross this off and write N, so I have the right elements, and there are 2 nitrogens, and on the product side, we have 3 and 2. So it looks like our magnesiums are the ones that are not balanced. So I need to put a 3 in front of the magnesium on the reactant side, and now it is balanced. With this next reaction, I have 1 boron, 3 chlorines, 2 hydrogens, 1 oxygen on my reactant side. On my product side, I have 1 hydrogens, I have 3 oxygens, I have 3. So remember, the trick is to save your hydrogens and oxygens until last and balance everything else first. So it looks like the only other thing that's unbalanced is my chlorines. So I'm going to put a 3 in front of the HCl on the product side. And in doing so, I have 3 plus 3, I have 6. I had 4 hydrogens to start. I had 4 hydrogens to start. Then I'm going to put my 3 in front. And so I have 6 and 3 here. Now on my reactant side, I need to get my hydrogens to 6 and my oxygens to 3. So I'm going to put a 3 here. Hydrogens turn to 6, oxygens turn to 3, and now everything is balanced. With this next reaction, I'm going to fill in my tables first. So I've noticed that my fluorines are not balanced, my hydrogens aren't, and my oxygens aren't. So I'm going to save my hydrogens and oxygens till last. My fluorines, I have 6 fluorines on the product side, but I only have 1 on the reactant side, so I need to put a 6 here. And that changes my number of fluorines, and it also changes my number of hydrogens to 6. So now that's the only thing that is left to balance are my hydrogens and oxygens. So I've noticed that my hydrogen has 6 on the reactant side and my products have 2. So I'm going to put a 3 here, and in doing so, I now have 6 hydrogen and 3 oxygen, and everything is balanced. In the next reaction, I have 2 aluminums and 3 oxygens on the reactant side, and 1 aluminum and 1 oxygen on the product side. So what I need to do is balance my aluminums first. So I have a 2 here. but my oxygens aren't balanced. So now I need to figure out my least common multiple because 3 and 2, they don't go into each other evenly. So I need to have a least common multiple. So the least common multiple of 3 and 2 is 6. So from 3, how do we get 6? We multiply it by 2. And now I've changed my aluminums to 4. My oxygens are 6. Over on the product side, I have 2. How do I get 6 from 2? I multiply by 3. But then I now need to change that number because my aluminums have now changed to 4. So I need to put a 4 in front of the aluminum on my product side, and now it is balanced. So we can balance the following reaction one of two ways. So I'm going to do the normal traditional way first. And I've set up already the initial starting amounts of reactants and products. So remember, we save our oxygens and hydrogens till last. So I can pick an element to balance. So I'm going to try to balance my aluminums first. And by doing so, I'm going to put a 2 here. And that changes my numbers to look like this on my reactant side. Now I need to balance my sulfurs. And on my reactant side, I need to put a 3 in front of my H2SO4. And my numbers will change to look like this. So now that's all that's left is to balance my hydrogens and oxygens. So it'd be easier on the product side to balance the hydrogens first because hydrogen only appears in the H2O. So I'm going to I have 12 oxygens on the reactant side, so I need 12 on the product. Oops, that's 12. And then my total number of oxygens ends up being 18 as well, and this is balanced. So the other way that we can balance this equation is by keeping the sulfate groups together when we balance. So in doing so, we'll balance the sulfate groups as a whole. And so when we're counting our atoms, we have 1 sulfate group on the reactants, and we have 3 sulfate groups on the products. Then we need to determine the number of, so aluminum, we had 1 and 2. Oxygens, we have to count the number of oxygens that are not attached to that sulfate group. So we have 3. And the number of hydrogens that are not attached to any polyatomic, and we have 3 and 5. And over here, the ones that are not attached to our polyatomic, we have 1 oxygen and 2 hydrogen. So then we balance our sulfate groups. So I have 3 sulfate groups on the reactants, so I need to put a 3 here. That changes the number of sulfates, and it changes the number of hydrogens to 6. I then need to balance my aluminums. So I put a 2 here. And my aluminums are balanced, and then my oxygens change to my oxygens that are not attached to a sulfate group. 2 times 3 is 6. And my number of hydrogens, 3 times 2 is 6. 3 times 2 is 6, so 12 total hydrogens. Now, my only thing that's not balanced are my oxygens and hydrogens that aren't attached to a polyatomic. And I have 12 hydrogens and 6 oxygens, which means I need to put a 6 here. And so that's the other way we can balance, by keeping that polyatomic together. So this one can be a tricky one because the only thing that's not balanced as of right now is my hydrogens. But hydrogen appears in 2 places in the products. So this is really just a guess and check. So I'm going to try, because I have 2 hydrogens or 3 hydrogens over here, but it appears in 2 different places. I'm going to start by just putting a 2 in front of my water. And in doing so, I have 4 total hydrogens and 2 total oxygens. On the product side now, I need to balance my hydrogens, or balance my oxygens and my hydrogens. So my oxygens, I need to put a 2 here, and I'm left with 2 oxygens. I am left with 4 total hydrogens and 2 sodiums. So I put a 2 in front of here, and now it's balanced. You could have easily picked a different number to start. And maybe you picked 4, and you ended up with 4, 4, 4, 2. Well, this answer is not in the lowest whole number ratio because they all have 2 in common. You could have divided, and you would have gotten this answer. The next question says, choose one of the above balancing problems to explain how you balanced it. Make sure you use the terms coefficient, subscript, reactants, products, and number of atoms. So the answers will vary on this, but in order to earn full points on the test, you must be very detailed in your answer. You must identify the reactants and products, and you must use the terms correctly, and you must accurately describe the process. So you won't get credit for the question if you write, I balanced it the way Mrs. Sommer taught me how to do it. You need to describe the way I taught you how to do it in order to receive credit on that question. The next question says, what 3 things have to happen in order for a reaction to occur according to collision theory? So according to collision theory, the particles must first collide. They must have the correct orientation, or other words, favorable geometry to collide, and the particles must have sufficient energy or speed. Next question is define activation energy. Activation energy is the energy required for a reaction to occur. So the next question is sketch a reaction graph and identify the activation energy required in the graph. So here's my graph, and the distance between the reactant's energy and the top of the curve, so this distance here, is the activation energy. So the last section is factors that affect reaction rate. And in this section, you're going to have to be writing answers on the test, explaining what factors and how did the reaction rate occur, or the factors that affected the reaction rates. So the first question is, why do you think it's a bad idea to have a pressurized tank of oxygen near an open flame? Use what you know about factors that affect reaction rates to explain your answer. So in your answers, you must include words from this list, okay? So increasing the pressure decreases the volume of the container, which means more oxygen molecules in a smaller area. You increase the rate of any reaction with oxygen molecules. Oxygen is flammable, and when you have more oxygen molecules in a smaller space, you create a perfect condition for an explosion. The next question is, why does sugar dissolve more quickly in hot tea than in cold tea? And the answer is increasing the temperature of the water causes the water molecules to move faster, increasing the rate at which they come into contact with the molecules, which increases the chances of a successful collision. The next question is, how do you increase the surface area of an object? You increase the surface area of an object by breaking it into smaller pieces. If a catalyst is added to the reaction, what happens and why? The reaction speeds up because a catalyst lowers the activation energy for a reaction. So it makes the reaction easier to happen. The next question is, if I want a reaction rate to increase, what could I do to the concentrations of the reactants? To increase the rate of reaction, I can increase the concentration of the reactants. I hope this review helped. Please let me know if you have any questions, and I hope that you enjoy whichever holidays that you celebrate in the next few weeks. And I will see you either third or fourth quarter.